Good afternoon. My name is Karin Habshi, and I will give you the CFD lab. Now, the lab is related to the course because in the course we will introduce you to the theory of computational fluid dynamics. So you'll understand the different algorithms, the different models used, and this will help you into doing the appropriate selection when it comes to a certain practical project. Okay, so in the lab we will focus on different application of CFD. We will do several engineering examples. We will, for example, consider a heat transfer application. We can design a heat exchanger. We can study for a certain room. We can study the HVAC configuration. You know, if it's in office, the recommendations are different than if it's in a hospital. So each space will be characterized by certain standards for thermal comfort, for air quality. And of course, air quality is of high importance nowadays. So the spread of particles within the space should be controlled. This is why computational fluid dynamics is very helpful, is a very interesting tool that can be used in a lot of engineering applications. Also, you can use it to model pumps. You can use it to model turbines. So you can imagine a lot of applications that can be used. It can be used also in the design of cars or airplanes. So from here, the importance of CFD. So as we said, in the lab, we'll focus on different applications. We'll try I will propose for you several projects, and also you can suggest a project that interests you. So our main purpose will be to develop your skills into using a certain CFD software to solve a certain engineering problem. So we'll do several examples together, and you will select a certain topic on which you will conduct your final project. Okay. Now, so as we said, the goal of this course will be to develop practical expertise in solving CFD problems with a commercial CFD code, and to develop an awareness of the power and the limitation of CFD. So we will see also, we should always, when we deal with the software, we should understand well its limitations. So, sometimes we should do several iterative procedure before coming up with the final mesh. So if you start with your problem, you might need to test several meshes before saying that this one is fine and it's giving me good physical results. So the purpose of this course will be to give you tools to assess the quality of a mesh. How many elements do I need? Are my results physical or not? What are the criteria for convergence, etc. So to be able to do this, we should develop understanding of the conservation laws. So the theoretical part of the course will help us in this. And then we'll apply this understanding to fluid motion and heat transfer and many other basic computational methods, including explicit, implicit methods, discretization techniques and schemes, and we'll understand more about their stability and how to deal with divergence problems. So sometimes when we do the run, we might have unphysical results. Also, the residuals might diverge. So this will be an index that something is not going well. So I might go back to the mesh, enhance its quality again, and I will repeat this work until reaching a satisfying results. So if we go through the outline, so first we'll do like a problem setup together, just as a small example that will help us into knowing the main steps that can be used in CFD. So, and while doing this, we'll have an introduction to ANSYS Fluent. which is a powerful CFD software that, as I told you, can solve a variety of engineering problems. So we will learn how to define the CFD problem, how to create or import the geometry in Design Modeler. Design Modeler is, if you want, the place where you can create your geometry in ANSYS. Now, in ANSYS Fluent, you have the ability to import your geometry from AutoCAD, from Inventor. Okay, but in general, it's better because sometimes importing a geometry might cause some problems. This is why I advise you, if possible, to draw the mesh on ANSYS, on Design Modeler of ANSYS Fluent. This will facilitate for you and things, and you will encounter less problems when you do your simulation. So after the first step, which is the geometry, which consists on just drawing the space of interest, we'll have to divide it into small control volumes. This is called the meshing part. Okay. Now, how many elements do I need? At which location do I need to have fine size of elements? Where can I have larger size? So all of these techniques will be developed in the meshing part. So we'll perform for the first weeks work on how to create a geometry, how to mesh it, and we can discuss several possible topics that we can do during the semester. Now we will do some applications related to conservation laws, and you can have heat transfer applications, you can have turbomachinery application, you can have aerodynamic applications. So we have a wide range of engineering applications that can be used. Now, also, as we introduced in the course material, the step of determining the appropriate boundary conditions is very important. So we should know, depending on the case we are studying, what will be the boundary conditions that should be imposed on ANSYS Fluent. So this is an input that you will impose, and based on this input, you will get the output provided by the numerical computation of CFD. Also, we will tackle together the concepts of convergence and discretization schemes. In parallel with the course material, we'll see what are the techniques used for discretization of equations, which will consist on changing the equation from analytical form to numerical form, as we discussed yesterday. And we'll see in applications the different turbulence models. So the theory of turbulence models will be developed in the course material. And in the CFD lab, we can test these turbulence models to see how they work, and in which applications we select this turbulence model, in which applications we can select another model. What is nice about Fluent is that even if you are new to it, you always have a help option. So in any model, let's say, whenever you want to select a model, you have an option to select help. It will tell you that this model, for example, is used in such applications. So by doing some readings, you can know characteristics of this turbulence model and decide if it's convenient for you or not. Now, we'll also investigate laminar and turbulent flows. So one nice application will be laminar pipe flow. Doing this can help you into verifying that your CFD work is going well, because you know that theoretically you can predict the laminar pipe flow. You know the profile, so you can go to a CFD book, and from the book you can get the theoretical results of laminar pipe flow. And to make sure that you are using CFD in a good way, you can try to simulate the same situation and measure and compute the velocity profile and compare CFD to analytical results. This exercise will help you to know what are the strategies that can help me into enhancing the performance of my numerical simulations. So how I can test that the mesh is good. How can I if you want, enhance my results. So sometimes if I increase the number of elements, if I use a finer mesh, I might have a better accuracy of my results. So this will help you into developing and testing these techniques. And then you can move to more complex scenarios as turbulent flows and other engineering problems that do not have engineering analytical solution. Now, for meshing is one of the most important steps in CFD. Okay, because if you don't have a good quality of your mesh, you might have very bad results, or you might have divergence of your results. So this step, we'll study it together. We'll see what are the different strategies to enhance the mesh quality. We have some, if you want, index to control the mesh quality as that will be introduced, like the skewness or the orthogonal quality or the aspect ratio that will introduce when we talk about the mesh. Now you have several types of mesh. As we said yesterday, it depends on the geometry of your problem. If you have a complex geometry, you cannot use, for example, just rectangular elements, because to be able to trap your curves, you need a flexible meshing. So you might have to use elements that are have random orientations, that are not uniform in size. So you can have, let's say, a variety of meshes, like tetrahedral or hexagonal meshing techniques, etc. So this is for meshing. Now, after introducing all of these, we'll do practice on several ideas. So, for example, we can consider, let's say, flow through piping systems and accessories such as valves, tees, and reductions. You know from fluids that all of these accessories will lead to losses, and you were used to call them in fluid mechanics minor losses. So you can test the pressure drop through these accessories by numerical simulation. So you can simulate the effect of a valve, of a T in piping systems, and how we can predict the pressure drops through these accessories, velocities, and vortex formations. Vortex formations is related to turbulence effects that we observe in fluid flow. We can also study, for example, HVAC configurations. So you know that you have different ventilation configurations offered, and the most common one here mixed ventilation, but we can see that it's not very efficient on we use it a lot because it's simple to install, and it's one of the first types of ventilations that were used. But we'll see that we can study a lot of other ventilation techniques that can lead to a reduction in energy savings while maintaining good thermal comfort qualities. So one application also will be to test different ventilation configurations and how these configurations will affect the energy consumption. A heat application will be heat exchangers. You already, if you have already taken heat transfer course, you know that you have several configurations of heat exchangers, and each one is characterized by a certain efficiency. So you can use also, CFD can be used to test efficiency of heat exchangers and compare different configurations. So if you can study the effect of counterflow, parallel flow, cross flow, etc. Okay. Also, an interesting application is renewable energy. So we can study the effect of windmills. We can study the lift that is the lift forces acting on the blades of a wind turbine. So we can study also velocity and power generation at a given wind speed. So this is a renewable energy application where we can use also CFD. As we said, also CFD can be used to test the performance of a pump. So you can test the design of a pump, of a turbine, of a diffuser, of a nozzle. So as you can see, you have different applications from different engineering fields, This makes computational fluid dynamics very interesting. And I hope that at the end of this course, this lab will help you. Maybe you might need it into your final year projects. So I hope that you will benefit from it. Because all of you are taking the course at the same time, to facilitate things on you, I might, for the project, it can be unified. So you have to do one big project, but of course, because you are taking the lab, the project should be more advanced. So the project can be common between the course and the lab, but you will need to take more advanced ideas because you will take the lab and you will do more practice than students that are just taking the course. Okay.
Okay.
Okay. So this is in brief the outline. Now concerning the grade distribution, so you will have 10% on participation and attendance. We'll do mini if you want. Concerning, because as I told you, so because all of you are taking the course, we can reduce the load a little bit. So instead of a final exam, we will consider just a final project, and during the semester we'll just have some mini projects so that you do some practice on different CFD applications that will help you to develop techniques that you can use in your final project. So we'll not do exams if you want in the lab. Exams will be just done for the course material. And concerning the text, so here this is more a practical, it's a lab, so you have more a practical aspect, but we suggest these books because you need to know the theory of CFD to understand the tools that you are using. Since all of you are taking the course material, so you will be, these ideas will be introduced through the course material. We will go over the different algorithms and schemes that are used. And in this way, in the lab, you will do more practice about what you will learn in the theoretical part of the course. Okay, so the books, the textbooks are similar to the ones we use in the course material of CFD.
دكتور
Yes.
كيف حنشتغل during the semester؟ يعني مثلا حضرتك حتفتحي معنا meetings online تشتغلي
Okay.
قدامنا أو حتنزلنا
Yeah,
tutorial؟
exactly. Look, I know that as a lab, it's a little bit challenging. This is why what I used to do for lab courses, اللي بعمله إنه أنا I record sessions on my own بدون ما يكون في ما يكون في students, and I post these recordings for you. يعني ساعتها لأنه أنتوا بس بدنا نشتغل لاب بتكون جربوا أنتوا تعملون on your computer صح؟ So what I will do, I already started to prepare some recordings. I will take a certain example. هفرجيكم كيف بنعمل الجيومتري، المش، السيت اب، السوليوشن. So you will try to do this work on your own as a practice to be familiar with the software. And once you do this on a weekly basis, تصير نزلكم YouTube tutorials covering variable applications, and you will try to do similar things, or do, if you want, you can take the tips for a certain idea and then you can develop it for your projects. So this will be the strategy we'll do. And when we'll be back on campus, inshallah, we can meet together. And if you, from now until then, you will decide on a certain topic for your project. And we will meet on campus so that I can help you if you have any difficulties that you faced during the MASH part or during the geometry part. So we'll do, if you want, the project during the lab together, and any difficulty you face, we can go through it. So this will be the strategy in general.
اوكي تمام. ويعني ما حيكون عندنا meeting كل ويك؟
هلا if needed بنعمل اوكي. يعني اول فتره حيكون انا عامله already recordings اعطيكم اياها. اوكي. واكيد بالكورس ماتيريال حيكون في weekly meetings to go over the theoretical part. اوكي. حتى في بارت حتكون common بين اثنين، لانه even بالكورس ماتيريال حابين انه بالسيلابس محطوط انه لازم يكون في شويه practical side. so حيكون في common parts between the two، وانتم حيكون عندكم two links، يعني one for the CFD lab, one for the course material.
اوكي كثير منيح. لو كان عليك سؤال صغير، آه، انه يعني بكره في حال مثلا قلت لنا انه بدنا نكون اون كامبس، حيكون الاون كامبس بوقت الصف، او معقول مثلا نقول نظبط شي وقت معين، يعني مثلا نقول شي مره نكون عندنا سي اف دي الكورس مثلا، معقول نضل شوي من بعده او شيء؟
yeah, I don't mind. I'm flexible with this. يعني قد ما بدكم.
لا
إذا if you have courses only on TTH مثلا, I don't mind إنه بعد الكورس material نقعد شوي سوا تنكمل اللاب. It's fine. We can arrange this. Don't worry about it. Okay.
اوكي ديل تمام، كثير منيح. وواضح انه الكور يعني حلو، واكيد حنستفيد منه
إن شاء الله. Any other question?
دكتور،
Yeah.
أنا ما فهمت كتير البروجكت. أنت بدك تحدينا عن شو بدنا نعمل، ولا نحن بنحدد عن شو بدنا نعمل
هلا جيل
البروجكت؟
انا بعطيكم different topics. I suggest for you different topics. بس انتم كمان اذا في شيء براسكم I don't mind. يعني بمجرد ما تكون heat application او fluid mechanics application، يعني حيلا application related to mechanical engineering او to engineering, it's fine for me. اوكي. يعني يلي عنده idea حابب يعملها I will accept of course. واللي بحب انه انا اعطي proposition هحط list of topics and you can select one of these topics. في كتير ideas فيك تشتغل عليها، يعني في كتير possibilities of projects.
أوكي دكتور.
Any other question?
Yes, doctor. Are you going to upload the syllabus with
Yeah, of
course
course.
content?
Yeah, everything. I will upload for both the course material and this one, and I will, as I told you, I will create a YouTube playlist and I will post all recordings on it. Today I will do this.
Deal. Thank you.
Okay. Any other question? Okay. So hopefully we'll meet tomorrow together for the course material, and I will start to from next week. I will start to upload for you recordings that I already prepared to introduce you to ANSYS Fluent. So please try to download it as soon as possible. أنا already I talked with Dr. Nimmer, and he told me that there is someone at UZEC that can help you to download it. They can send you a link and you can download it. Another possibility is to have the free student version. So try the links your colleagues sent on the group. If it's not working with you, let me know. I will contact Dr. Nimmer because they can help us from UZEC to get a free student version.
دكتور، قد ايش السايز تبع السوفت وير؟
هو الستودنت فيرجن ما كتير، يعني هو السوفت وير تقيل، يعني حتى الكراك، حتى الفيرجن يعني اللي هي الخفيفه منا قليله، بس انه بيحملوا الكمبيوتر، يعني اكيد بيحملوا. دونت وري اباوت.
انه هلا انا الايتو تقريبا، ما بعرف اذا هو بس عم بتاكد 1.3 جيجا بايت.
هلا في different versions. اوكي. وحسب اذا كراك فيرجن او لا، حسب قد ايه كمان الليميتيشن، لانه بحطوا لك انه في منهم مثلا ما بيقدر يعمل بالسيموليشن let's say اكثر من 1000 او 10000 iterations، يعني اذا كثير complex geometry ما في يعملها. اوكي. هلا نحن مبدئيا البروجكتس حناخذهم انه شيء feasible. اوكي. يعني بالنهايه انه you are new to the software، يعني تا واحد يفوت بجوه شوي وياخد بروجكت، مش دغري حياخد بروجكت very complex. اوكي. فايتس فاين. مبدئيا هول الفيرجنز حتى الليميتد 1 حيمشوا معكم. اوكي.
Okay, doctor.
Okay, any other question before we stop? Okay, so let me know if you face any difficulties. Try to use the links sent on the WhatsApp group. And in case you were not able to download it, we can see what to do, okay? We can arrange, لأنه في, I think, we have also a lab of computers where you have answers on the computers in Isaac, and the responsible there told me that he can send you a link and you can use it, but I don't know if he is available now. I will contact Dr. Nimmer in case you were not able to download it, but try to do it on your own. In case it was not possible, I will contact Dr. Nimmer so we can get the link, and if they can help us in the procedure so that all of you can download it and have it.
دكتور فيني ابعت لك صورة على الواتساب تتأكد إذا هيدا هو السوفت وير اللي حنشتغل عليه؟
ايه اكيد. هو اسمه
أوكي.
ورك بنش، اسمه ورك بنش انسس، وبقلبه في الفلوينت. هلا اذا بدكم I will ابعت لي انت البيكتشر وانا كمان
دكتور احنا
ببعت لك اللي عندي.
شغالين بس قصص ستريس وهيك قصص.
يلا let me check.
static
Did you can you send it please على الجروب؟
يلا بعتها هلا، ما بعرف إذا
Yes, I think that's it. At the left, okay, عندك fluid flow fluent. هيدا هو، okay. هيدا هو السوفت وير.
اوكي هذا هو.
So please can you send the procedure to your friends to help them؟ يعني انت كيف نزلته؟
دكتور بهيدا الويب سايت اللي بعثت لهم هو في توتوريال، يعني بالاخر في فيديو بحط لهم كل شيء بالتفصيل كيف بينزلوه.
Great. Okay, very good. So this is the software. So please just use the link your friend sent on the group, and you have a video which will explain for you the different steps to download it. Okay. So bye. See you next time.
Thank you, Doctor. Bye.
Welcome.
يعطيك ألف عافية.
Thank you,
باي.
Doctor.
Thank you, doctor.
Thank you. Bye.
Bye.